Good morning, everyone. So, in our last class, we were studying the normal forms and we discussed first and second normal form. So, today we shall discuss the third normal form and the bisecond normal form. So, the third normal form is dependent on transitive functional dependency. So, which means it is a functional dependency that is transitive in nature. So, a transitive in the sense a functional dependency like x deriving y and y deriving z. So this can be implied that x is deriving z. So such relationships of functional dependencies, so we call it as transitive functional dependencies. So this transitive functional dependency is also valid in the relation schema. So the meaning of x determining y is, so the x set of attributes will uniquely determine the value of another set of attributes, that is y. And y is a set of attributes that is uniquely determining the value of z attributes. So we can indirectly imply that x is determining the value of z via the attribute set y. So this is transitive functional dependency. So transitive functional dependency is a functional dependency x determining z that can be derived from two functional dependencies. So that is x determining y and y determining z. So in our example of company database, so if we consider a relation with the following attributes, that is SSN of an employee, department number of an employee, and department manager SSN. So if in any relation, if we have these three attributes, then the functional dependencies that exist over here is, so SSN is determining the department number of an employee. So based on the SSN, we can decide which employee belongs to which department. So that is one sort of functional dependency. But on the other hand, the department manager SSN is dependent on the department number, because it is the department number that will determine who is the manager. So another functional dependency that exists in this scenario is the department number will determine the department manager SSN. So now when we apply the transitive property, we can deduce that indirectly SSN is determining the department manager SSN. So this transitive dependency exists in this particular table. So which is not allowed, which is not valid in a relational schema. For example, so SSN cannot determine the department manager SSN. So that has to happen through the department table. So this kind of transitive dependencies we must identify in third normal form. So third normal form is based on transitive functional dependency. If there are any transitive functional dependencies, then the table has to be decomposed, which means we will divide the table. So another example you can look where there is no transitive dependency. So for example here, so SSN determining employee name is not transitive because there is no set of attributes x where we can write SSN is determining X and X is determining employee name. And there are few exceptions for a functional transitive functional dependency. So we shall see them. So based on this transitive functional dependency, so the 3NF is defined as a relational schema is said to be in third normal form if it satisfies the second normal form and no non-prime attribute of a relation is transitively dependent on a primary key. So the transitive functional dependency for a non-prime attribute should not occur. So the relation will be decomposed into third normal form relation via the process of normalization. So in the previous example, when we had a relation like this SSN, department number and department manager SSN, we will decompose the table. So on the first, we will write SSN determining, that is department number. We'll put these two in one table, and in another table we will put department MGR SSN. So that is on the other side. So two tables will be decomposed. So why this decompose was necessary? Will it lead to redundancy or will it be leading to anomalies? So that we need to understand. So if in any department, let us assume there are 25 employees. So there are 25 employees in a particular department. Next, if there are 25 employees, how many times the department MGR SSN is stored? So if we follow this particular relation, then the MGR SSN is also stored 25 times, one per employee, which means there is a redundancy. 24 times extra we are storing the department manager SSN. So what we'll do in place of that, we have to split it. Will it lead to anomaly? Yes, it will lead to insertion anomaly. What if the department has no manager? If you want to change the manager of a department, then we have to update it at 25 locations. So those redundancy and anomaly problems will occur if there is a transitive functional dependency. And this transitive functional dependency is for the attribute which is not prime. So in this case, in this table, the department MGR SSN is the non-prime attribute and SSN was the prime attribute, and a non-prime attribute was transitively depending on a prime attribute. So since there is a non-prime attribute depending on a prime, there exists the functional dependency. So the transitive relationship should be from the prime attribute to non-prime. So only this sort of transitive dependency we will encounter and decompose the table in 3NF. So the transitive functional dependency should be between a prime attribute and a non-prime attribute. In this case, we will decompose the tables. And there are scenarios where this decomposition is not necessary if the transitive dependency is not via a non-prime attribute. So consider an example over here. Employee SSN, employee number, salary. So three attributes are there: SSN, employee number, and salary. So the functional dependency that we can establish here is SSN is determining the employee number. Okay. And employee number may determine the salary, right? So in this case also there is a transitive dependency because SSN is determining the employee number and employee number is determining the salary. But in this scenario, the employee number that is acting as a intermediate attribute, it is also a candidate key. So candidate key means it is also a contender for a primary key. So one more additional thing that we must consider when we have a functional dependency is the intermediate set of attributes which we have should also be a non-prime attribute. So if it is a candidate key, then we cannot consider it as a transitive under 3NF. So we'll no need to decompose the table. So only when a prime attribute is dependent on a non-prime attribute transitively via a non-prime attribute, then only the decomposition is done. So the general form we can use and define the uh, various normal form. So the definitions which we used so far will use only primary key. But when we define these normal forms, we must consider that there will be the candidate keys. So there may be multiple candidate keys. So if there is only one candidate key, that can act as a primary key that itself. But if there are multiple keys, then we must replace all our definitions where we used the prime attribute with key. So because every prime attribute is also a key. So in our definitions, we must replace these terms. So a second normal form we can rephrase as a relation R is said to be in second normal form if every non-prime attribute A in the relation is fully functionally dependent on every key of R. So earlier in place of key we had primary key. Now we have to say it is key. So similarly we have to redefine the third normal form also. So super key of a relational schema is a set of attribute S of a relation that contains a key of R. So based on this, so the third normal form is defined like this. A schema is R is said to be in third normal form if whenever a functional dependency like X determining A holds, then either X is a super key of R or A is the prime attribute of R. It's a reverse. So instead of defining it based on the transitive functional dependency and saying that non-prime attribute is depending on a prime attribute via a non-prime attribute, So we can say if there is any functional dependency like this, then the X has to be super key of the relation and A has to be a prime attribute of R. So if A is not prime attribute, then this should not be super key. Or if this is not a super key, then this should not be a primary key. So based on the extension of this third normal form, we have another normal form, that is Boyce-Codd normal form. So in Boyce-Codd normal form, the second condition is not allowed. So we shall look at that next. So a relational schema R is said to be in Boyce-Codd normal form. So in short form, we call it as BCNF. If whenever a functional dependency X determining A hold in a relation R, then X is the super key of R. So X must be super key. So each normal form, whatever we discussed, so it is stricter and stronger than the previous one. So second normal form, to be in second normal form, the relation should be in first normal form. To be in third normal form, the relation should be in second normal form. To be in BCNF, the relation should be in third normal form. So there are relations which are in 3NF but not in BCNF. So the goal of an application developer or database designer is to have their relation at least in BCNF or 3NF. So consider this particular example. So this is Boyce-Codd normal form. So the relation contains property ID, country name, lot number, and area. So you can also call it as a location. So the functional dependency is the property ID is determining the country ID, location ID, and area. And another functional dependency we can establish over here is the country and location is determining the area and the property ID. And the area is determining the country. So area ID is determining the country. So we have this three functional dependencies over here. And it is again all these functional dependencies, whatever is defined, that depends on the application and how a designer deals with the attributes and the information that is captured in the database. So when this undergoes the uh, BCNF normalization, so here the property ID, area, and location on one side, and the area country name is on the other side. So this is because, so this country name, it is depending on area, and area is being determined by the property ID. So this functional dependency, if we write the short forms for this P, C, L, A. Then the dependency that we can make out are P is determining C, L and A, and CL is determining the PA, and A is determining C. So when we have this kind of situations, you can observe that here P is determining C and A is determining C. And in BCNF, so this has to be the left side of a functional dependency has to be a super key. But if you observe here on the left side, we have A, which is not a super key, and also we have on the other side C and L, which is not super key, but P is a super key. So since this is the case, we will divide the table into such a way that it will be in BCNF. So property ID, area, location, area and country name on the other side. Now for a given property, will we get its country name? Yes, via area we can get its country name. So no information is lost over here. So in so the next example is this one. Consider this ABC attributes. So this ABC attributes, so if we just write the functional dependencies, it is A, AB, it is determining C, and C is determining B. Now let us check whether 3NF is followed here. So 3NF says there should be no transitive dependency of a non-prime attribute. So is there a transitive dependency here? So A and B both determining C and C is determining D. So there is no transitive dependency. So if there is no transitive dependency, we can say that this particular relation is in 3NF. Now verify whether this is in BCNF. So what does BCNF say? BCNF says the left side of this functional dependency should be a super key. Whether AB is a super key? Yes, it is. Whether C is a super key? It is not. Because C is being determined by A and B together. So this particular example, it is not in BCNF. So if it is not in BCNF, so how we can convert it? So here we can divide it into a table like this. So A and B in one table and B and C in another table. So this way we can divide it, or we can also divide it like A and C in one table and B and C in another table. So in this way also we can decompose it. So this can be decomposed in two ways. So with this, so we can differentiate between the um, BCNF and the 3NF. So whenever there is a non-trivial functional dependency like this, okay, then according to um, BCNF, according to BCNF, this has to be a super key. So that is the condition. Whereas in 3NF, the condition is either this should be super key or this should be a key. So that is a difference between these two. So the difference between 3NF and BCNF. So if you observe this, so BCNF is more strict than 3NF. Okay. So it is important to remember that the condition here is R. If any one of them is satisfied, then we can say that the relation is in 3NF. So in 3NF, we can say that non-prime attribute determines another non-prime attribute. So that is important in 3NF. So in 3NF, there will be transitive dependency, and in transitive dependency like this, X determining A and A determining B, and this A is non-prime and B is also non-prime. So that we can note over here that it is the non-prime attribute that is determining another non-prime attribute and which is not allowed in relational schema. So a non-prime attribute cannot determine another non-prime attribute in the relation. So a proper subset of a key can functionally determine the non-prime attribute. So that is the 3NF and BCNF. So another example of a relation which is in 3NF but not in BCNF. So here the functional dependency that we can make out is the student and course is determining the instructor and instructor is determining the course. So in the previous table, the two functional dependencies that exist is so student, course and instructor. So two functional dependencies exist over there. So instructor is decided based on a student and a course. And for each course, there will be an instructor and instructor will be delivering a particular course. So again, the functional dependency of instructor to course is there. So if this is the case, then the student comma course is a candidate key for this relation and that the dependencies should follow is in 3NF, because there is no transitive dependency. So there is a, so this particular relation is in 3NF, but it is not in BCNF. Why it is not in BCNF? Because BCNF says this part should be super key, whereas instructor is not a super key, whereas in this particular table, student and course is the super key. So the relation is not in BCNF, and it should be decomposed so as to meet the property that the left side of a functional dependency should be super key. So while possibly forcing the preservation of all the functional dependencies, we have to decompose the relation. So how we can decompose it? So yes, this particular example can be decomposed in many ways. So one is um, student instructor in the one relation. In another relation, we can have student and course. So on one side, we can have a course and instructor. On the other side, student and course. On one side, we can have course and instructor. On the other side, we can have student and instructor. So in many possible ways, this particular relation can be brought into the BCNF. So these are the possible decompositions we can lose. So all three decompositions which we have done will lose the functional dependency 1, but we have to settle for sacrificing that particular functional dependency preservation, but we cannot sacrifice the non-additive property after decomposition. So out of the above three, only third decomposition will not generate spurious tuples after a join. So all the primary keys are also mentioned over there. So if you observe here, in the first case, if we join the student and instructor based on the student, then there may be a possibility of a spurious tuple. And here these two tables join will happen based on course. So if we join based on a course, then again there will be a possibility of a spurious tuple. Then only in the third case, the spurious tuples may not arise. Okay. So with this, we completed the normal forms till BCNF. Okay. So we can quickly summarize the normal forms where we defined it based on the primary key. So for the first normal form, the relation should have no multi-valued attributes or nested relations or composite attributes. So if we have a multi-valued attributes or composite attributes or nested relations, so we will, what is the remedy? Remedy means the normalization process. So we will create a new table or new relation for each multi-valued attribute or composite attribute. So in the second normal form, how to test? So for a relation where primary key contains multiple attributes, so second normal form exists only when our primary key is composed of many attributes. So we have to test that no non-key attribute should be functionally dependent on a part of a primary key. So it must be functionally dependent on the whole primary key, not on the part. So if this test fails, in order to normalize this, what we must do is we must divide the table, we must decompose the table and create a new table where that partial dependency exists. So those two attributes will be, can be moved to that particular table. And for the remaining attributes, we must make sure that it is fully functionally dependent on the primary key. And the third normal form, the test we must make is for a relation should not have a non-key attribute functionally determining the another non-key attribute. So there should be no transitive dependency of a non-key attribute on primary keys. So this is the test we must do. So if this test fails, then what is the remedy? So we must divide the table and set up a relation that includes the non-key attribute that functionally determines another non-key attribute. So that dependency or non-key attribute determining another non-key attribute, those two can be moved to new table, and we can designate the non-key attribute that is determining as a key in that particular table. Okay. So with this, we can stop our discussion. So in our next class, we can discuss the multi-value dependency and fourth normal form, along with the joint dependency and fifth normal form.